You know when you look at a skyscraper that just seems to scrape the clouds, or a bridge that spans some impossible gap, or even an ancient pyramid just standing there against the sands of time, and you just wonder, how? Seriously, how did we go from huddling in caves to literally shaping the planet we live on? Well, today, we're going to dig into that story. We're unpacking the story of civil engineering, the invisible blueprint that our entire civilization is built on.
And let's just dive right in with a quote that honestly hits the nail on the head. This isn't just a story about concrete and steel, you know? It's about a fundamental human drive to build, to overcome, and to create a world that actually serves us better. It's a story that starts with our earliest ancestors, a story of pure ambition, etched in stone and steel.
In that story, well, it unfolds across 4 really distinct eras, and each one was a total revolution. So here's our roadmap. We're going to start with the foundational work of the ancient world. Then, we'll take a giant leap into the Industrial Revolution that changed absolutely everything. From there, we'll see how the digital shift is redefining construction as we speak. And finally, we'll get a little sneak peek of the smart, sustainable future that engineers are building for us right now. So, let's get started.
Okay, so our journey begins where humanity itself really started to get organized. We're talking about the very first blueprint. And this whole era was defined by one simple but monumental question. How do we not just survive in this world, but actually master it? How do we build for our community, for glory, and for something that will last for ages?
And the answers they came up with, wow, they were anything but simple. I mean, think about the Great Pyramid of Giza. It's aligned with cosmic precision, with millions of stone blocks placed so accurately it still kind of baffles us today. Or what about the Roman aqueducts? These elegant marvels of engineering carried fresh water for hundreds of miles using nothing but the gentle pull of gravity. And of course, the Great Wall of China, a ribbon of stone and earth stretching across an entire continent. These weren't just buildings, they were bold statements of human ingenuity, built with pure muscle, stone, and an unshakable will to endure.
So for thousands of years, the limits of engineering were really defined by what we could find in nature and the power of human and animal muscle. And then, the 1800s happened. And with a hiss of steam and the clang of steel, boom, the old blueprint was torn up and completely rewritten. Welcome to the Age of Steel.
And you can really see the massive shift right here. We went from muscle power to the raw brute force of steam. We moved from familiar stuff like stone and wood to the revolutionary strength of steel and reinforced concrete. And because of that, the scale of our ambition just exploded. We stopped building monuments and started building entire megacities. We turned mud paths into these intricate networks of bridges and railways that literally shrunk the world. Get this, in just 50 years, we laid more railway track than in all of prior human history combined.
So, by the 20th century, we'd pretty much conquered the physical world. We could build skyscrapers that touched the clouds and bridges that spanned enormous chasms. But a brand new challenge was emerging, and this one couldn't be solved with just brute force. It was a challenge of information, of efficiency, of just incredible, mind-bending complexity.
And that brings us to right now, to the modern era, where the most powerful tool on any construction site isn't a crane, it's not a bulldozer, it's data. We are now living in the age of the digital construction site, where the first brick isn't laid in the mud, but in the sterile, precise world of a computer. Now, the core technology driving this whole revolution is called BIM, or Building Information Modeling. In simple terms, think of it like creating a perfect, data-rich digital replica of a building before a single ounce of concrete is ever poured. Every single pipe, every wire, every structural beam, it's all in the computer first, along with its material, its cost, its installation schedule. This isn't just a 3D model, it is the ultimate blueprint. It's the thing that can prevent a multi-million-dollar disaster by spotting that, oh wait, a crucial ventilation duct and a main support beam are supposed to occupy the exact same space.
So, what this all means is we get to use this incredible build twice method. First, you build a perfect digital twin of the structure in the virtual world. And in there, you can simulate everything. Earthquakes, hurricane force winds, energy efficiency, even the logistics of construction itself. You find and you fix every single potential problem in the model, so that when you finally build it in the real world, you only have to build it once. Perfect. Okay, so if building with data is today, what about tomorrow? I mean, where does the blueprint even go from here? Let's take a leap forward into the near future and see what's coming. The rise of the smart city, which is really the culmination of everything we've built so far.
First off, the builders themselves. Yeah, they're changing.
We're talking about a whole new era of autonomous construction. I mean, imagine drones that can survey a site with millimeter accuracy in a fraction of the time it would take a human crew. Picture robotic bricklayers working 24/7 without ever getting tired, and massive 3D printers that can construct an entire house from the ground up in just a matter of days. This isn't just about building faster and safer, it's about a level of precision we've just never seen before. Next up, the very materials we build with are getting a radical upgrade. The ultimate goal here is a zero-carbon future, a world where our buildings aren't part of the climate problem anymore, but actually part of the solution. We're talking about developing new kinds of smog-eating concrete that literally absorbs CO2 from the air, or using sustainably grown timber that locks away carbon for centuries. We're designing buildings so energy efficient they actually generate more power than they consume.
And all of this, it's all leading to one mind-blowing idea: the city that breathes. Imagine a city that's managed by a sophisticated AI, a city that functions like a living organism. Traffic flow is optimized in real time to eliminate jams before they even start. The power grid intelligently shifts energy to where it's needed most. The buildings themselves adjust their own climate based on who's inside, saving energy and creating a more comfortable world for everyone. It's a vision of a city that isn't just smart, but is truly alive.
So we've really come full circle, haven't we? Our journey through the blueprint of civilization is wrapping up. We've traveled from the first stones laid in the desert, powered by nothing but human muscle and ambition, all the way to the dawn of intelligent cities built by robots and managed by data. The blueprint is always evolving, and it's a testament to our relentless drive to build a better world.
And at the end of the day, this is the timeless truth of civil engineering. From that first humble aqueduct that brought life-giving water to a thirsty city, all the way to the next generation of smart cities that will house billions, the fundamental goal has always been the same. It's not just about putting up structures of steel and glass, it's about building the very framework for the future of humanity.
But here's the thing, this incredible story of human ambition is far from over. It's a continuous project. Every generation adds its own chapter, its own innovations, its own dreams. And that leaves us with one final, really crucial question. What part of that blueprint will you help write?